Hi, Brendan Richards here at NDC Sydney. Today I'll be doing an Ask Me Anything interview with Danish software designer Mark Seemann. As well as writing open source code, Mark is best known for writing the book Dependency Injection in .NET. He also presents around the world and at user groups and conferences, and is a frequent guest on the .NET Rocks podcast. Mark, thanks for joining us today.
Thank you.
Let's start with your day job. What do you do day to day? What's your job title, and how do you spend most of your days?
Right, yeah. So I went independent like six years ago. It's basically been my experience that every year has been different than the year before. So what I do this year is not necessarily representative of what I did the previous years. But in this year, I've mostly just been writing a lot of stuff and doing a lot of videos, and just going to conferences and giving talks and stuff like that. So yeah, not a lot going on actually. Well, that is a lot, but it's not. I'm not really doing a lot of coding work for people at the moment. Unfortunately, I would love to do that, but
so you're a little bit off the tools at the moment.
I am actually, yeah. So there's this. So you probably we'll be talking about this later on, but I'm very much into functional programming. There's this thing people say. There's a quote that floats around says, "I love functional programming because it takes all the smart developers and make them completely unemployable because they're just going, I will only work with Haskell, and it's sort of like maybe I'm turned into that sort of person." I would love to find something to actually get my hands dirty again. I sort of need that, but in the meantime, I'm just thinking a lot about what programming actually means and what software is.
Good stuff. So in my interview, I mentioned your book, and a lot of the developers I know, they started it as the aha moment for themselves, and they actually got how to do constructor injection. But how did you go about starting to write a book? How do you decide that topic, and what's the process of actually? I assume it takes a lot of time.
Right. Yeah, well, it's sort of it's one of those things that just happened. It's many years ago now, but I was involved with the publisher Manning because I did other things for them as technical reviewer on some of the other books. So they just asked me. They were sort of considering doing a book on dependency injection. And they sort of just asked me as a technical reviewer whether I thought that was a good idea. And I just thought about it, and I thought, I actually do know quite a few things about this topic, so maybe I could write it. So I just, I had a call with the publisher, and I said, if I were to write the book, I would structure it like that. And obviously he said, would you like to write the book? And I said, yeah. I thought that was probably the plan all the way through, I suppose. So I had been doing some writing before. I had a blog going already at that time. I'd written some articles for MSDN magazine going even further back. So I wasn't completely a stranger to writing technical material already. So I thought it was a pretty natural thing to take the next step and actually write a book. And the mistake that everyone who has done an article before, the mistake that everyone makes is to say, well, okay, so if an article is like corresponds to 10 pages and you will have to write a 200-page book, well, that's just like 20 times that. Which it turns out not to be. Somehow a book is just a much more complicated affair. Although I can't really put my finger on exactly why that is, but it took a long time. But people seem to be pretty happy about it, and so I'm really happy with it for that reason.
It's definitely, so many people I've met have cited it as the thing that got them over the line. So let's move on to one of the main meats of this talk, and that's the idea of C#, F#, and functional programming. So obviously we all know C#, it's a great language and it's very capable, and
it is.
Being a Turing complete language, you can do pretty much anything with it. So why a different language at all? What do you get from switching to functional that you don't get elsewhere?
So there's lots of different things you can get, and again, when you ask about switching to functional, that could mean one thing. But if you just ask about switching to F#, that's a little bit of a different take. So we can start with that, if you will. But in general, I just say at a very high level, F# is just a better language, and one of the reasons it's a better language is because it's newer, and we as an industry we constantly learn new things. So some of the things that people may not have been aware of when C# was designed is we've learned from that experience, and that experience has been applied just F# in general. So I think just for that reason it's a better language. But I think there's a lot of things that makes F# a really nice language. But I think probably if I had to name one killer feature is that proper F# code doesn't have null. So there's a lot of interaction that you need to do with all the rest of .NET, and as soon as you start to interact with all the other .NET stuff written in C#, you still have to deal with the fact that these things will, might give you null objects back, and you need to sort of deal with that. But it also has very sane ways to do that. So you can do a little bit of sort of like an anti-corruption layer, if you will, and say, okay, I know this is something that is written in C#. I am not really sure whether it's going to return null or not. There's basically a one-liner. You can convert it into something that you can start to reason about. So it's not that F# and other functional languages don't have the concept of a value being present or being absent. That concept still exists, but it's just like it's something that is baked into the static type system in such a way that that you can actually look at a value and you can see this thing may not be there. It may be a value, but it may also not be a value. And now the compiler forces you to deal with both cases, whereas that's what C# doesn't do. Well, I know they're working on that right now, and that's a great step in the right direction. So maybe C# will actually become better in that regard. But I would be surprised if it catches up to F# in just one language version, maybe in a couple of versions, but not in the first one. Even if they have success with doing, non-nullable reference types. Yeah. I think it'll be a while before C# actually catches up and becomes as good at modeling that as F#. So just the fact that you can write your code and you can, when it compiles, you have a pretty good feeling, you have a pretty high degree of confidence that it's probably not going to throw null reference exceptions. Who wouldn't like that?
That sounds pretty good to me. I'd say 80% of the bugs I raise are some kind of null reference exception.
Yeah, exactly.
So if I can just wipe out 80% of all my bugs, that sounds like a good plan to me.
Yeah, but there's lots of other things that F# makes F# a really nice language. Another thing is that it has this overall idea of it has type inference that is much more stronger than C#. So you probably know a little bit of type inference from C# already, because sometimes the C# compiler can infer that you meant that specific generic type. So you don't have to explicitly state it. You could just say, when you call the select method on, IEnumerable of t, for example, you don't have to say select and then tell it what your, return type is going to be, because it can sort of figure that out for itself. But you just take this whole concept to the next level, because again, if you take proper idiomatic F# code, not the stuff that needs to talk to the rest of .NET, but functional F# code, if you will, you can actually write the code in such a way that you don't see the types at all. They're not declared. Whenever you write a method declaration in C#, you have to declare, you have to explicitly say it's going to return an int or a string or whatever it is that it needs to return. And here's an argument list, and this argument will be a string, and this argument will be a GUID, and so forth. So you need to be very explicit about it. And one of the things that can be a little bit bothersome in a language like C# is that if you decide to change the type of some of the arguments, it's a lot of work to actually go through all the compile types, breaking that causes. Whereas, an F# function, it's statically typed, but you don't explicitly write the types when you write the code. It's just the compiler figures that out from how you use the function arguments. So that means that if you decide that that function arguments, I made a mistake. It shouldn't have been, it shouldn't have been an int. It should have actually been a double or something like that, or decimal. You can just sort of change the way you use the argument, and then the compiler sees that it changed, and basically all that type information just ripples through the whole code base, and then other things change type as well. And if something is incompatible, you will still have a compile time error, but as long as everything still makes sense, the compiler just says, this still makes sense, and that's probably what you meant, and that's a good thing. So it also makes it's actually pretty refactoring friendly in that way, because you don't have all that explicit type information, which by the way also makes it absolutely excellent scripting language.
Yes.
So you can actually load F# scripts. You can have script files, or you can just use they have F# interactive, which is sort of like a REPL, read eval print loop. So you can actually just use that as a scripting environment where you can say, I want this to happen. I sometimes use it to test my REST APIs when I develop REST APIs. So I've written a little DSL that sort of just does the puts and the deletes and the posts that I want it to do. But it's statically typed, so I can take all the power of F# and compose all sorts of things, and then go and do an HTTP post over there, get the result back, parse it, and do some more stuff with it, just to interactively test these things. And that's a really productive thing. Very, very nice.
Yeah, we've certainly seen a little bit of syntax sugar changing around the C# world. Like the var keyword was never there from the start, and gives us the ability to not be quite so explicit.
Right.
But at any one point, that type is very explicit. It's just not explicitly stated all the time. So we are seeing some of those ideas flow through. But yes, certainly F# sounds like it's got much more in the way of letting that flow through.
Yeah.
So if you're looking to get started with functional, I know F# one language, and that's got the advantage of running inside the .NET framework.
Yeah.
But is that the best way to start, or is there another language?
Whenever people ask me that, I say it really depends on where you come from. For everyone coming from C#, I would definitely say F# is just the perfect next step, because the framework already. Yeah. So all the things you already know about .NET development still applies. Yeah. So basically, you can just take it probably takes you a couple of weeks just to get used to the syntax, and then you're basically saying, well, now I can write F# code. Will you, after 2 weeks, would you write perfect idiomatic functional F#? No. But you can learn that as you go along. That's what I did. I spent a couple of weeks learning the syntax, and then I started writing object-oriented F#, basically. And then I sort of figured out, I can do it that way. That's more functional. That's nice. So I just gradually moved towards something that's much more functional. So I think that's a very friendly way to get into functional programming. So I can really only report on my journey. Other people say that if they come from completely different background, lots of people have had good experience with Elm. Yep. Which is a client-side language that compiles to JavaScript. Never really had any experience with that at all, but I hear good things about it, so that might definitely be another option.
Let's say I've decided to go on a F# journey, and I've got my architecture, and obviously I'm pretty sure that I can't write, I wouldn't want to start by writing F# all the way through my entire application. Mm-hmm. So what can you tell me about mixing F# and C# code, and where would you draw the boundaries?
Well, this is really one of those questions where the answer is it depends.
Of course.
But there's sort of two different scenarios where I think F# shines. One is to just go F# all the way. Actually, that is a really, really interesting way of approaching application development, because by going F# all the way, you don't have to make any sort of compromises in the way you model your things, so that C# understands what you meant. And that means all the compile time safety you can get by saying, I want to cover all sorts of edge cases and make sure that it's not going to be null reference exceptions and all of that thing, that you can get that guarantee in an entire code base. So that's actually really valuable. But another successful way to use F# is if you have something that is if you have some logic that is actually fairly complicated, where the logic itself would benefit from a functional approach, then you can do this, mix F# and C# approach. But I think, in order for that to be advantageous, would require that you have some logic that is sufficiently complicated so that you would actually be able to derive a benefit from it. Because otherwise, I think you probably run into this thing where if you decide to say, let's say you decide to do if you're doing layered application architecture and you decide to do one of your layers in F# and all the other ones in C#, now you're having to go and marshal back and forth between the C# way of doing things and the F# way of doing things. And I'm not really convinced that in itself is beneficial. Okay. You need to have some reason to to mix things, if you will.
Yeah.
So I think, you don't have to have a reason to just write your entire application in F#, because the fact that the language is better is reason enough in itself. But if you want to do the mixing, there must be some sort of benefit to be derived from that. I have seen that. So what you can do is, if you have something that is sufficiently complicated or difficult to model in C#, you can write a little, F# module, and then you can give it a little API on top of that looks object-oriented, so that when C# client code comes and calls into it, it just looks like a normal object with some methods on. That's absolutely possible to do that way. F# is this multi-paradigmatic language, and it can do OO as well. And not only can it consume, object-oriented code, it can also, expose or implement OO code itself. So that's absolutely something I've seen, be successful as well.
So the key thing is there is a kind of boundary between them. There is effort to switch between. So you definitely have some kind of API between.
Yeah.
The two.
So to be clear, it's not so much. You shouldn't be concerned much about the boundary being something that takes a lot of processor time.
Yeah.
Because at the end, C# compiles to IL.
Yeah.
F# compiles to IL. So when it's running, it's just IL code talking to other IL code. So that's not so much the concern.
No.
The concern is more that there is some, F# is a more expressive language, and there are things it can express that don't translate very well into C#. So if you try to expose those things directly to C# code, well, you can consume it in C#, but it looks a little bit odd, and it's a little bit awkward to use, some of the F# specific things from C#.
Yeah.
So you'd often be, if you're in this mixed scenario, I think it'd often be a pretty good idea to just make it look object-oriented to the outside world.
So let's move on to unit testing.
Mm-hmm.
So is there anything different about how you go about unit testing under F#, and are the tools the same?
Well, there's a lot of similarities, and then there's some things that, again, I really love about doing unit testing in F#. But to start with, the things that are the same is, for example, if you like to use xunit.net, which I do, for example, that works with F# as well.
Great.
A lot of the test runners at least the test runner that I use, works pretty well with F# as well. So a lot of these things just are generally useful. And again, this is just because it's IL code. So at the end, it works pretty well. But the xunit.net maintainers actually did a little bit of work to get F# working well on xunit.net as well. So you can actually you can do some F# specific things in xunit.net, and it still works. You don't have to jump through hoops there. So that's really nice. And one of the things I think is really interesting about using F# for unit testing instead of C# is that there's this concept of property-based testing. And in short, property-based testing is this idea where you say, instead of just having, normally when you write a unit test, you just, either you hard code some, example input variables, and you say, I'm calling a method on my system under test, and I'm just going to hard code, some strings and some integers or whatever you need as input into the method, and then you verify that you got, whatever you expected back from it. And maybe you can write a parameterized test, with a little bit of, in XUnit that goes with a theory and some inline data. But you can sort of take that to the next level and say, what if instead of you just have a parameterized test with some inline data, what if you just randomly generated a lot of input values, and you just run the same test method 100 times or 1,000 times with lots of randomly generated data? This is called property-based testing. And it's not that you can't do it in C#. Actually, you can. But there's a really nice library called fscheck that implements that sort of idea. It's an idea that comes from Haskell originally. So fscheck is sort of like a port from QuickCheck and from Scala. There's another one called Hedgehog, which is also pretty nice. But the idea is the same. You just generate a lot of random data, and then you can sort of run your tests against that data. And I think one of the reactions an object-oriented developer would often have to that idea is to say, well, but if you just generate a lot of random data, wouldn't it cause lots of test failures? Because there's probably going to be data that would be invalid in that particular test case, which is also the case in functional programming, but there's a lot of things that cannot go wrong if you do proper functional programming, in the sense that if you don't mutate state, there's a lot of invalid operation exceptions that you're not going to see because you have weird sequences of input values that you weren't supposed to do it in that order or something like that.
Yeah.
You don't have that problem in functional programming. So that takes away a lot of the pain of doing randomized testing like that. And then again, all the property-based testing frameworks have nice APIs. So if you need a randomly generated value to be constrained in some sort, you say, well, I need you to produce a number, but it needs to be a number between 1 and 12, for example, because it's going to model the months or something like that. You can create you can plug into the framework. Well, it's not a framework; it's a library. You can plug into the library and say, give me numbers, but they must be between 1 and 12.
Yeah.
It's a pretty good APIs for doing that. And you can actually do it. You can use FSTech from C# as well. It actually has pretty good C# support as well. So it's not that you're completely shut off for being able to do that, but it feels more natural in F#. So that's pretty nice.
That's a good tip, because I know developers are great at writing tests for the perfect case.
Yeah,
They're
exactly.
Always great at writing tests for the edge cases. So you generate, sending in random values will generate those edge cases that you want to thought of.
It absolutely does, and it often surprises me because I'm writing a property and I'm thinking about the happy path. And then all of a sudden it explodes because there's some edge case that I hadn't thought about. And what that means then is I say, well, okay, I hadn't thought about that. I need to constrain the way that the random data is generated a little bit more, and then I need to go and write another test that verifies, okay, what happens if those in those edge case scenarios. So it sort of gives you inspiration for writing more tests in that way as well. So you often end up having pretty good confidence with that test suite, even though it doesn't look like it. There's a lot of tests, but each of them is running maybe 100 times. So yeah, it's pretty nice.
So the next question is, when it comes to writing tests, are there any other standard metrics you follow? Do you hold a lot of store in having a high code coverage, or how do you go about mixing setting the right level of testing?
Right. I don't look at code coverage myself anymore at all. I basically consider code coverage to be a completely useless metric as a target, that is.
Yeah.
So any organization who says you must have a code coverage of at least let's say 75 or whatever you come up with as a number. Whenever you do that, people will even unconsciously start to game that system. And that could actually, cause code to be worse than it would be otherwise. I've actually seen that happen. Can't think of examples right now, but there are some, where, for example, people say, I should really check for null here. But that means I would actually, checking for null means introducing a new branch. And introducing a new branch to my code will actually cause my coverage to go down unless I write a test case for that new branch. And I'm in a hurry and I don't want to do that right now. So instead of checking for null, I'm just not going to do that because it would hurt my code coverage metric.
Yeah, that's a case where writing and you looking at the code coverage actually produces worse.
Exactly, yeah. So I would really strongly, recommend that people don't use it as, an absolute metric. Now you might want to look at the trend though. And I've sometimes done that when I've been working with other people, just to keep an eye on what's happening to code coverage. And it's not that because generally you'd want it to go up or at least stay stable. Yeah. But sometimes it drops, and that doesn't necessarily mean that anything bad happened. It could just be because someone added a lot of. One example could be someone added a lot of auto-generated code. Yeah. And there's actually an attribute you can put on in .NET saying auto-generated, and then code coverage shouldn't take that into account. But sometimes that doesn't work. Yeah. So if you do that, you add a Windows Communication Foundation proxy, that would produce a lot of auto-generated code. And I've at least seen versions of that auto-generator not producing the correct, ignore code coverage attributes there. So all of a sudden you have added, 10,000 of lines of code, so your code coverage just drops. So when that happens, I'm more looking at what happens to code coverage, and if it drops dramatically, I want to know why, and then you can go and investigate or ask the developer who checked that in and say, why did code coverage drop? Oh, I created that WCF proxy, it's automated code. Okay, now I understand why. Okay, thanks, it's good. And now we should just hope to see it increase again. So that might be there might be a reason why you would do that. But again, it really depends on, do you trust your developers to write good tests, or don't you trust them to? Because if you trust them to write tests already, I wouldn't even bother to look at the trend. But maybe you don't, and then that might help you a little bit.
So you've talked about code coverage not being a good metric to determine quality of code. What is, not necessarily metrics, but what do you look for to evaluate that this is a well-written piece of code and what isn't? And it's a difficult question.
Yeah, that's a difficult. Well, I'm not aware of any metrics that will actually help me out.
I'm not saying metrics. I'm saying
no, I
look at a code base.
I understand.
What do you look for?
Right. I think the first thing I would look for is just to know how big are the chunks that the code is made up of, and that would go across C# code and F#. If you have C# code with hundreds of lines of long methods, that would be bad. And the same thing goes. I've seen F# code like that, where in a function, oh, here's good functional code, and then you just go like 300 lines of F# code, and I wouldn't be particularly comfortable with something like that either. So I think that's actually probably one of the most important things at all, is to keep it small. Because we really have a limited capacity in our brain to keep track of too much stuff. What all programmers do, as far as I can tell, is that when you're looking at code, you're sort of building up a mental model of how that code would execute, and you can keep track of a couple of variables in your head, but you can't keep track of 100 different variables in your head trying to build that model of how the code would execute. That's just not humanly possible. So, but that's basically what you have to do if you have to understand what a 100-line long C# method does.
Right.
So that's just really difficult to work with that sort of code. So that would be my number one thing to look for. Just is it small? Then I start to look a lot after coupling. And this is again one of those things where F# is really interesting, because when C# developers first come to F#, one of the things that really annoy people is that F# has this rule that seems unfair and unreasonable, that you can only use a piece of F# code if it's already declared before the point where you want to call it. So you can only call a function if you declared it above the code that calls it. You can only use a type if that type was declared above the place where you want to use the type. And people get super annoyed with that when they come from C# and say, this is the stupidest language ever. Why? But what it does is it prevents circular dependencies. So, and often if you look at C# and Java developers for that matter, the reason why people, myself included, try to split an application into several projects, that are several libraries. Like you have, your UI library, you have your domain logic library, you have your data access library, stuff like that, is because at the library level, at the package level, Visual Studio actually enforces that you cannot have cyclic dependencies. So this is a way to control or to prevent to have cyclic dependencies in the large. But then F# just does that automatically, even in the small, and that means all F# code is just much more linear in the way that dependencies work. It's basically just a graph of dependencies instead of all, but it's an acyclic graph, whereas C# code is often filled with cyclic graph. And it's just it just makes C# code much more harder to follow. If you're trying to build that mental model in your brain, what does this code do? Oh, this thing calls this thing over there, that calls this thing over there, that calls back into, oh dear.
Does that have any impact on how you write recursion? So you can't have recursion where you're jumping between two functions. It has to just be the one function calling it.
There is some extra keywords you can add where very specifically for recursion, you can have a recursive, two recursive functions that are mutually recursive.
Okay.
There's a keyword for that in F# that actually enables exactly that scenario. But usually you don't even need it, but because most of the times if you have that sort of scenario, you can refactor it to something that is not mutually dependent. But in a pinch, you can do the other thing. Yeah.
Good stuff. One more thing from your blogs and stuff is one thing you're definitely into is looking for patterns in maths and then applying them to code.
Right.
So have you got any examples of some things? And I think functional programming is definitely, because it's got such a stronger fundamentals in the maths world,
right.
It's definitely a place for those patterns to start to apply. So have you got some examples of things that you can use to make your code?
Yeah, it actually started many years ago. So there's a reason why I got interested in this. I didn't, if you told me 5 years ago that I would become super interested in, pretty abstract mathematics, I would have said, why would I want to do that? But the reason was that many years ago I started doing test-driven development back in 2004. I think it was the first time. So I did a lot of test-driven development and tried out all sorts of different techniques and so on. And after having done that for like 6, 7, maybe 10 years, I started to notice that sometimes, when you do test-driven development, you often do lots of dependency injection.
Yes.
That's how I got interested in dependency injection, actually. So I noticed that you tend to create lots of interfaces when you do TDD, and sometimes the interfaces turned out to be really powerful in the sense that they could compose, and I could have multiple implementations of the same interface, and they composed well, and I could create composites out of them and stuff like that, and they just seemed to be very reusable. And then I had other interfaces where I would have that interface, and I would have one implementation of that interface, and it just seemed to resist any sort of reusability, if you will. And I was at that time already pretty well aware of the fact that an interface that only has one implementation is probably a sign that it's not a good abstraction. So I really wanted more of my code to be those powerful interfaces that actually had multiple implementations. But I couldn't really put my finger on, why are some of them powerful and composable, and why are some of them not? So I looked at it for many years, and I couldn't really figure it out. And I sort of tried to sketch out what I thought I'd found out, and I actually wrote a blog post about that, from 2010, where I sort of tried to feel my way through, what is it? And then I basically gave up on it because I couldn't really make a systematic approach to it. And then I became interested in functional programming for completely different reasons. Yeah. And I started to look into what's F#, and then I started to look into Haskell, and Haskell has this strong connection to category theory. And I was looking a little bit into that because I thought, well, what is all of that about? Maybe there's something interesting going on here. And then, one day it just struck me that, there's this concept that's actually not even in category theory so as much as just abstract algebra that's called a monoid. And a monoid is a thing that composes. And then through a lot of small brain explosions, it dawned on me that the composite design pattern is actually just a monoid. And you can basically just run a little bit of a check. If you can just look at an interface and say, it's built from smaller monoids. So if all the methods are monoids, and you can sort of just look at them and say, you don't have to know about implementation. You can just look at the type and say, that could form a monoid, that could form a monoid, that could form a monoid. All right, this is composable. So now I actually know, how do I create a good abstraction that composes and is reusable? Well, that's one way. Make sure that it forms a monoid. Not to get into what a monoid is here, but that is a very, very abstract thing that actually has quite a practical, application, because you can now look at a tentative interface design that you have, and you can say, will this be something that looks promising and will be a powerful abstraction going forward? And you can basically just take, for example, that little test and say, okay, is it a monad all the way through? Not a monad, a monoid.
Yep.
And if it is, it will be a composite, so it will be good. And then you can do, similar things with some of the other very, very high level ivory tower, abstract things. Turns out to be actually, I think they have quite practical applicability actually. So it was a little bit of a coincidence I got started on this, but now it's just, totally, invaded my brain. So that's basically all I can think of these days.
I've got one more question before I open it up to the audience, and that's, I know F# has got quite a small team in Microsoft. What would you like to see to get F# bigger, get more people using it? How can we kind of, you're obviously making these talks and you're out there selling the ideas. How can we make F# grow in adoption?
Right. Well, so the first thing we have to acknowledge is that there is a fantastic open source community that actually does a lot of the work with F#. And the few employees that are actually in Microsoft that are, in Microsoft in order to do F# also do a fantastic job. There's just not very many of them. So it's really, really important that open source community exists, and it does. So you can go and contribute to the F# core libraries if you want. There's a process where you need to go through a review of the proposed feature and so on. But you can, and people do that. It's if you hear the actual number of Microsoft employees that work on F#, you would say, that's not sustainable. But then there's this open source community that actually really multiplies the effort. So the language is still alive. But I think one of the things I'd really like to see Microsoft doing is that I would like to see them treat it as a first-class language, because they say it is, but it isn't. It's a first-class language in the sense that it is as supported in live environments as C# is. So in that sense, it's a first-class language. But if you look at all the tooling that Microsoft produces, it's always like, you have these new great features in all, in Azure and in Visual Studio and all sorts of other things. And it's always like, it's designed for C#.
Yeah.
And then you say, well, does it work with F#? And the rest of Microsoft goes, gee, we don't know. We haven't tested it. And so, and often it turns out that it doesn't. And then, again, this open source community heroically scrambles to make it work with F# as well. But you just get this impression that, it's not a priority. And I think that's a pretty fair thing to say, that it's not.
Well, I think with Microsoft Microsoft is moving in the right direction, but a lot of these things take a long time. Take, for example, dependency injection. We've had dependency injection from Java for a long, long time. The .NET community finally started taking it up, but it was the alt.NET community, the people that moved from Java to .NET, that then started taking it up. Then finally, when .NET Core came out, I think it was about 2 years ago, the early previews were starting to float around. And then finally, we had dependency injection as a first-class citizen across the Microsoft stack, which then meant the dependency injection builders didn't have to try and hack dependency injection into the framework, because it was there from the beginning. And so it takes a long time for these things to move all the way into the stack.
But I have to disagree with you that that's actually a good thing, because the way that they actually build baked dependency injection into some of the new frameworks is the wrong way to go about it, in my opinion. Because it's, there's always been dependency injection in .NET itself, from 1.0, because dependency injection is just based on this idea of polymorphism and inversion of control, which is not a technology, it's not a framework, it's just you inject interfaces or base classes into the constructor of a thing, and then it works with that polymorphic object. That's all dependency injection is. And people always go around and have this, wrong notion that dependency injection has something to do with a DI container, and that's, I think, the wrong way to move. Lots of other organizations, and even in the Java community, it seems to me now, when I talk with Java people, they've realized that the best way to do dependency injection is to not have a DI container, but just inject whatever you need when you need it. So that's what I've always done. So I think it's a little bit of a move in the wrong direction to have this, universal DI container that is in some .NET Core libraries now. I'm not a fan.
Oh wow,
Yeah.
so interesting viewpoint.
So we actually have a second edition of Dependency Injection in .NET coming out pretty soon.
Oh yeah, when's that due?
This year. So 2018, before Christmas, we hope, because it will make a fantastic Christmas gift, will
I
it
think
not?
so. I was going to ask you if you had anything to plug, and yeah, it's coming up soon. So yeah, make sure you look out for that version. Is it second edition now? Isn't
It's
it?
second edition, yeah. And we do talk about what we feel about, dependency injection in .NET Core, for example.
Excellent. Good. Look forward to that. Okay, so now I'm going to throw open the room for any questions. There is a microphone on the table in the corner, so if you've got the questions, we're recording and transmitting live, so please step up to the mic and ask your question.
Could you please summarize, this is an ongoing debate between inheritance, people who prefer inheritance and people who don't. Could you please explain your take on this and what are the alternatives?
So you mean like inheritance versus composition as the kind of standard?
Yeah. I think, again, this is a little bit language dependent, because the main problem with inheritance is that, in a language like C# or in Java, whenever you derive from a base class, you basically shut off all other options for being polymorphic in any other direction, because you can't derive from, two different base classes at once. And there are other languages that actually allow that, and then inheritance may not be as bad in those languages. But this is sort of me hand waving a little bit, because as far as I remember, you can do multiple inheritance in C++, can't you?
Yes, you can. Yeah.
But I've never really done that in C++, and it's like 20 years ago I wrote my last C++. So
and the big argument against multiple inheritance in C++ seems to be when you when you have the same kind of function in the two parents. What happens when you try and call that function? The methods, in the child. It
seemed to me like the way that, Eiffel, which was, Bertrand Meyer's original idea about object-oriented programming, it had multiple inheritance as well. And as far as I understood it, it actually had a fairly sane approach to that particular problem. But I've never written any Eiffel code, so I don't know how it worked out in practice. It may have turned out to be not a good thing in practice. I wouldn't know. But I think that's probably the main reason why I prefer to avoid, inheritance in C# is that, I don't want to, if I make the wrong decision in terms of what I should, derive from, then that is a really difficult, decision to change. Whereas, if I decide to implement an interface, then I can always just remove that interface declaration from a class or add another one, and it's not nearly as expensive. But another thing that I've also experienced throughout the years is that small APIs are better than large APIs. So if you have a little interface with, let's say, 2 methods, something like that, that turns out to be much easier to actually go and implement in various different ways. Whereas if you have an interface that defines 20 different methods, you probably only have one class that implements that interface, because that interface is very specific to a certain set of capabilities, if you will. So what often happens with inheritance is you have those big base classes that sort of tries to provide as much functionality to the classes that to inherit from them as possible. And that just makes them less composable. One example of an interface that's already growing too big is something like collection interfaces in .NET. Because one of the collection interfaces in .NET has something that says something like there's a read-only, is read-only. And then if you want to implement a read-only collection, you have to return true there, but you still have to implement all the things that can, like the add method for a collection. You still have to, it has to be there. So you have to throw a not implemented exception there. So it's sort of like the more you see interfaces where you have to, throw a lot of not implemented or not supported exceptions in your interface definition, that's a pretty big sign that something is growing too big. So that's just a general symptom that big APIs turn out to be not particularly composable, whereas if you have small interfaces, you can always add, you can have one little interface and another little interface, and you can say, I have a class that implements both of those, that's fine, But you couldn't do that with base classes, because you can't say, here's a base class that has this little capability, and here's a base class that has this other little capability. Well, you can't derive from both of them. So it's a little bit hard to describe without looking at a lot of code, and this is one of those things where I would even have to think a little bit, in order to come up with a good code example. So this is sort of my best attempt at just, shooting from the hip, at giving you an answer to that question. But I'm definitely in the camp that prefers, interfaces over base classes. And I've written code in C# for more than a decade, basically without using base classes at all. So I know that it's possible to do. You don't need, inheritance at all.
Okay, well, we're running out of time. So thank you very much for listening, and thank you very much for your time, Mark.
Sure.
And I have been Brendan Richards. You have been watching SSW TV. Thank you.